students, welcome back to Organic Chemwords. Let's find out how many lone pair of electrons are present in the final product T. The benzene is undergoing series of reactions and forming the final product T, from which we have to identify the number of lone pair of electrons. The first reaction is a chlorination reaction where benzene is reacting with chlorine in presence of the catalyst aluminium chloride, and it forms chlorobenzene. This is a classic example of electrophilic substitution reaction where the hydrogen is being substituted by the chlorine. Now, the chlorobenzene reacts with the nitrating mixture, nothing but mixture of nitric acid and sulfuric acid. It's going to form nitrochlorobenzene, but are we going to get mononitro, dinitro, trinitro? We don't know, and this is the most confusing factor for many of the students. I'm going to give you a hint here. So whether the product formed is mono, di or tri depends on the group present on the benzene. Here we have chlorine, which is a plus R but minus I. So it deactivates benzene ring through inductive effect. So that's why the benzene is not so rich. Hence, it's undergoing electrophilic substitution only once. And since chlorine is a plus R, it will be ortho-para directing group. So this is ortho-para directing. Since there is a steric hindrance at the ortho position due to chlorine, the incoming nitro electrophile will go to the para position. Therefore, you are going to get the para-nitrochlorobenzene like this. So it's mono-substituted chlorobenzene molecule. Now, this is going to react with KOH, a base. Generally, the reaction is done in high temperature, at high temperature or high pressure. Why so? Because the molecule is undergoing aromatic nucleophilic substitution reaction, which is also known as SNAr reaction. The nucleophilic substitution is happening at the aromatic ring, right? The carbon of the aromatic ring. So this reaction is quite difficult because of the partial double bond due to the resonance of lone pair of electron from chlorine to benzene. So that's why generally we do this at higher temperature. But in this case, we also have an electron withdrawing group. This will help this chlorine to leave the molecule easily. So that is the driving force here. Therefore, this will undergo nucleophilic substitution and it will form a phenol. But since there is a basic medium, what happens? It will be a salt of the phenol. So it will be potassium salt of the phenoxide ion like this. That's why in the next step, the adding H plus. This is just to neutralize the reaction. So we are going to get the phenol now. So paranitrophenol like this. Then this is treated with zinc HCl. So this is a reduction. So which group will undergo reduction here? Nitro. Nitro is susceptible to undergo reduction and it's going to reduce to amine group. That is para-aminophenol will be the product. Now, the last step. It is treated with acetic anhydride and it is only one equivalence because both hydroxyl and NH2 can be undergoing acetylation. So that's why one equivalence is added. And here, since nitrogen is less electronegative as compared to oxygen, this is going to react with the anhydride molecule. Right? So to be precise, it will add to this carbon and then it will go as acetate. So the acetylation is happening on this nitrogen. So let's write down the final product now. So you see there is a OH here. Then we have NH. The hydrogen from the NH2 will go with this acetate and it will form acetic acid as a byproduct. So our main product. So that's why you see there is acetic as a byproduct. And then here we will have COCH3. So how many lone pairs are there? So for that you should be familiar with the Lewis dot structure. So the Lewis dot structure will tell you that on oxygen there are 2 lone pair of electron. Nitrogen is trivalent, that means there is 1 lone pair, and don't forget about this oxygen. So there will be 2 lone pair. So altogether 1, 2, 3, 4, 5. There are 5 lone pair of electrons on the final product T. I hope I made this concept clear to you, and if you still have any question, you can always comment them in the comment box. And if you have not subscribed to the channel, please do subscribe and support me. Thank you.